Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at part 2 of Euclidean geometry, solving circle geometry problems, finding reasons for statements, and we are continuing with the November 2019 paper 2. So in this particular video lesson, we're going to be concentrating on question 10, which reads as follows. In the diagram below, O is the center of the circle, P, T, and S are points on the circumference of the circle. P, S, P, T, and O, T are drawn. So if you look at this, they're saying prove the theorem which states that SOT equals 2 times SPT. Now, if you look at my website, which is jrmaths.com, you'll be able to view the video of the theorem which states the angle at the center is twice the angle at the circumference, which I've already proved there. But very quickly, when you are proving theorems, the most important thing for you to be able to do is to remember what the construction will be for that theorem. Construction will be for us to join OP, produce a line OP, and we can draw it to any variable that we want. So we've got P, O, and let's just call that K. So therefore, the next step would be to call that O1 and O2, and let's call that P1 and P2. So now by doing that, we've actually now got radii, which is OS equals to OP, which is equal to OT. And we've also got triangles where we have equal angles opposite equal sides. In triangle PSO, you have P1, which is going to equal to S, and you've also got P2, which is going to equal to T. So basically, we're going to be showing that P1 equals to S, similarly P2 equals to T, and then we're going to say that O1 is going to equal to S plus P1, and O2 is equal to P2 plus T, the exterior angle of the triangle. And we'll eventually be able to show that SOT is 2 times SPT. So once again, the most important point to remember in this particular question is to remember the construction and how to label your diagram. And then the proof becomes quite easy to do. And once again, if you want to learn this particular theorem, you can look at jrmaths.com. Now, let's look at question 10.2. In the diagram, O is the center of the circle. Points A, B, C, and D lie on the circumference of the circle. BOD is a diameter. AC and BD intersect at E. A1 is equal to 51 degrees and B1 is equal to 29 degrees. So let's go and have a look at what we have. When you are given the center of the circle, remember that you need to remember angle at center equals 2 times angle at circumference. Also, line from center. Remember that the line from center, which is drawn perpendicular to the chord, bisects the chord, and a line from center perpendicular to the chord bisects the chord, and a line which is drawn to the center of the chord is perpendicular to the chord. Also, when the center of the circle is given, remember that you are most likely going to be given diameter and radii, which you need to take note of. Like for example, here you've got the following. You can see O is the center of the circle, which means that OC is going to equal to OB radii. But also you are given that DB is the diameter of the circle, which means that this angle here is equal to 90 degrees, angle in a semicircle. So when you read the following diameter, you must know that you are most likely going to be given angle in semicircle. So these are all the reasons that you are likely going to be using when you are going to be doing your solution. So always go to the diagram and try to answer as many of the questions as you possibly can by filling in all of the angles that need to be filled in. Like for example, remember here you've got A1 is 51, right? Now if you look at this particular chord, which is BC, or the arc BC, remember the angle at the center is twice the angle at the circumference. So therefore O1 is going to be 2 times 51, which is going to be 102 degrees. And as we've already identified that DAB is going to be 90 degrees angle in semicircle, so therefore A2 is going to be 90 minus 51. What is 90 minus 51? That should give us 39 degrees. So 39 plus 51, so that's 51, 60, 90 degrees there. And if you got 90 there, 90 and 29, remember that D and B1 now will be complementary angles. So therefore, this particular angle here will be, so we should have an angle of 61 degrees, 61, 70, 90 degrees. Okay, so O1 is done. We've got that angle there. And what about this angle here? 61, 39. So that'll be 61 plus 39 is 61, 70, 100. So that'll be 80 degrees there. Vertically opposite angles, that's going to be 80 degrees there as well. Okay, so these are all the things that we must be able to identify in our question. Right, so now let's have a look and let's go and see, well, can we answer any of the questions? Determine the size of O1. Do we have it? Yes, we do. There's O1 here. 102 degrees. And what will our reason be? Angle at center is twice angle at the circumference. A2. Do we have A2? Yes, we got A2, but we'll tell them first that DAB is 90 degrees and then we can find A2. So there you go. A2 is done. D. Yes, we've got D, sum of angles of triangle. We've got that one. So that's one mark there. And determine the size of ACO. ACO. Let's go and look at ACO. ACO. So basically C1 there, right? Yep, I think we got it. How are we going to get that one? Remember, the exterior angle of a triangle is equal to the sum of the interior opposite angles. So that will be 102 minus 80, and that should give us 22 degrees there. Right? So we'll have to find DEA, which will be 80. Then we'll say that CEO is 80 degrees, vertically opposite angles. And then we'll say that C1 is equal to 20 degrees exterior angle of triangle equals to the sum of the interior opposite angles. So we can now say that we've got all the marks there. Okay, so once again, remember, proof is on jlmaths.com, and remember, the most important thing to remember in any proof is the construction. Okay, now let's go and write down these solutions to this particular question. What is the size of O1? Size of O1, 10.2.1. So we'll say O1 will equals to 102 degrees. Angle at center is equal to 2 times angle at circumference. 10.2.2. Determine the size of A2. So now we'll say A2. The first thing we'll say is that A is going to equal to, angle A is going to equal to 90 degrees, angle in semicircle. So we'll say A equals to 90 degrees, angle in semicircle. Therefore, we can now say that A2 is equal to 90 minus 51. Therefore, A2 is equal to 90 minus 51 degrees, and 90 minus 51 degrees is 39 degrees. Let's go look at the next question. 10.2.3. Remember, we are retracing our steps. D is going to equal to 61 degrees, sum of angles of triangle. 10.2.3. D will equal to 61 degrees. Sum of angles of triangle add up to 180 degrees. And 10.2.4 ACO, and we're gonna find ACO by finding DEA, which is 80 degrees, sum of angles of triangle. Then we're gonna say CEB is equal to 80 degrees, vertically opposite angles. And then we're gonna say that C1 is going to equal to 22 degrees, exterior angle of triangle. Or you could just simply say that, if you have to look at this, this is also an exterior angle of a triangle. So you could say CEO will equals to 80 degrees, exterior angle of triangle equals to the sum of the interior opposite angles. And then we can say C1 equals to 22 exterior angle of triangle as well. So basically in this question, we've got 2 reasons exterior angle of triangle. Okay, so let's go with that solution. So 10.2.4. So I'm going to write down CEO equals to 80 degrees exterior angle of triangle. Now remember that I've already showed that O1 is 102 degrees. So therefore now I can just simply say that C1 equals to 22 degrees. And once again I will say exterior angle of triangle. And that will be my solution for question 10. Learners, if you haven't subscribed already, subscribe to JL Maths. You also can like my Facebook page, which is Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.